Hey class, we're going to continue our study of the transportation problem with two more algorithms for finding shipping policies, the least cost method and Vogel's approximation method. So like the northwest corner method, both of these algorithms utilize the Tableau representation of the transportation problem, right, which was that chart that we had seen. However, unlike the northwest corner method, these two algorithms will consider associated shipping costs when constructing a shipping policy, and will thus produce better results, generally. So this, of course, comes at a cost of increased complexity, right? So within every step, we'll be looking at the shipping costs, and there may be many shipping costs because there may be many distribution centers or source locations, if you will, and many destination locations or stores, if you will. So at each step, you have to look at each of those, which is something that you didn't have to do in the northwest corner method. Completely disregarded those. All right, so we're going to begin with the least cost method, or LCM. So this algorithm is a heuristic, greedy algorithm that focuses on shipping as many items as possible from source locations, right, which we said were kind of like warehouses or distribution centers, to destination locations, which we said were like stores, with the lowest cost per item. So we'll see what that means. So again, least cost method emphasizes taking advantage of cheap shipping from source locations to destination locations. So we'll see that in the example and also in the algorithm steps. So what are the steps of this algorithm? So for a Tableau, we locate the empty cell with the lowest shipping cost, right? So the shipping costs in a Tableau were the values that we write in the upper left-hand corners of each cell. So presumably before we start this method, we will have filled out the Tableau with the information of that transportation problem. So we identify the empty cell with the lowest shipping cost. If there's a tie, what we do is look at the smallest rim condition for each of these tied cells and select the cell with the largest of these values, right? So every cell is going to have two rim conditions, right? And we look at the smallest rim condition, right, of the two for each cell, and that cell that has the largest, right, of these rim conditions, of these smallest rim conditions for each cells, is the one that we select for step one. All right, so for that cell, all right, so that's step one. Step two, for that cell selected in the previous step, we choose its value, so the value of the cell, right, what we put in the main part of the cell here. This is the shipping cost associated with that cell. This is the main value. So we choose this main value, right, and these were the rim conditions for this particular cell. So if that's unclear to you, then I suggest you go back and watch one of the two previous videos, so either the northwest corner method video or the introduction video. I think I discussed it in both of those. Definitely the introduction video. Anyway, so we choose its value, so the value of that cell, to be the smaller of its two rim conditions. So if they're both the same, just choose the row rim condition, then subtract this value from the other condition. All right, so step three, if the rim condition chosen in step two was the row condition, we cross out the row the cell was in, like the entire thing from the Tableau. If the rim condition chosen was a column condition, we cross out the column the cell was in, like the entire column. So this is a step that's very identical to one that was present in the northwest corner method. So then, step four, we repeat steps 1 to 3 for all remaining, so not crossed out cells, until a single cell remains, right? So at this point, there should be a tie for the rim conditions of both the row and column for this cell, and we just take this value to be that of this cell, right? And then this ends the procedure. Okay, so this is very similar to the northwest corner method, right? In that we're identifying a cell, we're choosing one of its rim conditions, and then we're crossing out either the row or column based on which rim condition was chosen, and then we repeat this until there are no more crossed out cells. So it's very similar in that regard, right? The least cost method to the northwest corner method. Except the criteria by which we choose a cell at each step is different. So in the northwest corner method, we were only concerned about position, right? We chose the cell that was in the upper left right corner of the tableau. In this case, we look for the cell with the lowest shipping cost, right? Okay, so let's see this algorithm in action for the given example problem, right? And this is the example problem. It's identical to that which we had used for the northwest corner method, right? So again, here it is. So suppose we have 3 Apple stores in Hamilton County, which need to stock up on the new 2020 MacBook Air ahead of its release. So we have stores 1 and 2. They're located in relatively low traffic areas and thus require only 40 and 50 MacBooks respectively. Store 3 is located in a busy mall and therefore requires 60 MacBooks. Apple has 3 distribution centers around Ohio which have in stock 70, 30, and 50 MacBooks respectively. The cost per MacBook to ship from Center 1 to each store, 1, 2, and 3, is $2, $4, and $2 respectively. The cost per MacBook to ship from Center 2 to each store is $3, identically. And lastly, the cost per MacBook to ship from Center 3 to each store is $1, $2, and $3. Alright, so let's take this information and fill in this tableau with that information, and then we're going to apply the least cost method to obtain a shipping policy. Okay, so I have this problem rewritten here for the Vogel's approximation algorithm. So let's, take this information from this problem, it's the same problem, and fill this tableau in with it. Okay, so let's fill in the room conditions. So store 1, or distribution center 1, so D again stands for distribution center, S stands for store, so these are the source locations and these are the destination locations. I know that's very confusing given how I've chosen to denote them, but that's what it is. So D is in distribution, not as in destination. S is in source, or S is in store, not as in source. Okay, so anyway, so these are the distribution centers, right? And so the distribution center 1 has in stock 70, right? Apple has 3 distribution centers which have in stock 70, 30, and 50. So distribution center 1 has 70, distribution center 2 has 30 MacBooks, and distribution center 3 has 50 MacBooks. Okay, now let's do the rim conditions for the stores. Okay, well, stores 1 and 2 require 40 and 50 MacBook Airs respectively, while store 3 requires 60. So another hint as to what these are and what these are is, the values in these cells should correspond to demand of the row, of the thing in the row, and so what has demand are the stores or destination locations. And these rim conditions correspond to those of the column, so these D's, and also the supply. Since there's supply, that means that these are distribution centers or source locations. Okay, all right, now, so what other information goes in this tableau? Well, the shipping information, right? The shipping costs per item. All right, so here we have that the cost to ship from center 1 to each store, right? Distribution center 1 to each store is $2, $4, and $2 respectively. So $2, $4, and $2, right? So stores 1, 2, and 3. The cost for distribution center 2 to ship to each store is $3 identically. And the cost for distribution center 3 to ship to each store is $1 for store 1, $2 for store 2, and $3 for store 3. So there we go. This is all the information that goes in a tableau. All the information that's relevant to a transportation problem, or at least the ones that we'll be looking at. Like I said in the Northwest Corner Method video, you may have additional constraints that we had seen that are similar to those that we had seen in linear programming problems where maybe distribution center 3 has to ship no more than twice as many resources or MacBook Airs to store 1 and store 2, various other constraints on what these values can be. But for these problems that we're looking at, that's not the case, right? And then also we assume that each distribution center or each source location can ship to each destination location or each store, all right? So the tableau is filled. Now let's apply the LCM, all right? So the least cost method. Okay, so for the least cost method, we first identify, right, the empty cell with the lowest shipping cost. Okay, so let's look here, right? So this is the cell with the lowest shipping cost, right? It's 1, everything else is either 2, it's 2 and above, all right? So there's no tie, so we don't have to do a tiebreaker, right? So once, that's step 1 is identifying that cell with the lowest shipping cost and breaking any ties, right? And selecting a cell appropriately. So we found our cell, right? So for the cell selected in step 1, we choose its value to be the smaller of its 2 rim conditions, okay? And then we subtract this value from the other condition. Well, the rim conditions are not the same, right? So the smaller of the 2 corresponds to the row rim condition, so we choose that value to be the value of this cell, and we subtract that value from the other rim condition. Okay? All right. That's step 2. Step 3. If the rim condition chosen in step 2 was the row condition, we cross out the row, while if it was the column condition, we would cross out the column. The rim condition that we chose for the value of the cell was the row, so we cross out the row. Why do we do that? It's because we've already satisfied one of the rim conditions for this row, right? Or, well, we've satisfied the rim condition for this row, meaning that the sum of the values of the cells in this row equal the demand, equal the rim condition. So we don't need, no values need to be placed here and here because we've already satisfied the demand in store 1, so we cross it out, right? Okay, step 4, we repeat steps 1 to 3 for all remaining not crossed out cells until a single cell remains. Well, we have still 6 cells, right, that we either have to fill in or cross out, or, well, cross out ultimately. Okay, so we identify the cell with the lowest shipping cost, right? So there are 2. So we repeat step 1. That was step 1. So there are 2 here. Now we need to figure out which one to choose, right? So what we do is we look at the rim conditions for each cell. So this cell has as rim conditions 50 for the row and 10 for the column, right? And we take the minimum of those 2, right? So this has minimum rim condition 10. Then we look at the other cell, and we find its minimum rim condition, right? It has rim condition 70 and 60. The minimum of those is 60. And then we take, of these 2, we compare that minimum rim condition, and we take the one with the highest minimum rim condition, right? So 10, 60, this one has the highest minimum rim condition. 60 is greater than 10, right? So this is the one we choose from step 1. All right, so then we do step 2. For that cell, we choose its value to be the smaller of its 2 rim conditions. Then we subtract this value from the other condition. Okay? Alright, so we take the value of this cell to be the smaller of the 2, which is 60, and we subtract it from the other one. Okay? Alright, that was step 2. Step 3, if the rim condition chosen in that step, the previous step, was the row condition, we cross out the row the cell was in. If the rim condition chosen was the column condition, we cross out the column. Well, we chose the row rim condition to be the value of this cell. So then we cross out the row. Okay? And then again, step 4 says we repeat steps 1 to 3 for all remaining not crossed out cells until a single cell remains. We still have 3 cells that weren't crossed out after all of that work. So we repeat the procedure for these not crossed out cells. So we find of these cells the one with the lowest shipping cost, right? The lowest value in the upper left-hand corner. That would be this cell, right? Okay, so that's step 1. Step 2, we choose the value of this cell to be the smaller of its 2 rim conditions, right? And then we subtract this value from the other condition. So the smaller of these 2 is 10, and we subtract that from the other. So that now becomes 40. Okay. All right. Okay, and then subtract this from the other, and if the rim condition was the row condition, we cross out the row that cell was in. If the rim condition was the column condition, we cross out the column that cell was in. In this case, it was the column, right? We chose the column rim condition of this cell. So we cross out the column, and then we repeat steps 1 to 4 for all remaining not crossed out cells, so these 2. Right, so then we look at this cell, right, or we look at these cells that are not crossed out, and we repeat steps 1 to 4. So we find the one with the lowest shipping cost, which is this one. We take the value of this cell to be the smaller of its two rim conditions, which is 30. Then we cross out the row or column to which the rim condition belongs. So it was the column rim condition, so we cross out the column. Then subtract that from the other rim condition. Okay, so I'll write that out here, right? And then we have one cell left. Okay, so now we're at step 4. We have one cell left. The two rim conditions are the same. We choose that to be the value, and we terminate the procedure. Okay, so here we have the final shipping policy. We send 40 MacBook Airs from distribution center 3 to store 1. We send 10 from distribution center 3 to store 2. 30 MacBook Airs from distribution center 2 to store 2. And 10 MacBook Airs from distribution center 1 to store 2. And lastly, 60 MacBook Airs from distribution center 1 to store 3. Okay, and we can see this is a valid shipping policy because the sum of the cells in each row don't exceed the demand, or at least meet the demand, are equal to the demand, right? So 50, right? 30 plus 10 plus 10 is 50, 40 is 40, 60 is 60, right? So we've met the demand of all destination locations, or all stores. And then, likewise, the sum of the values of the cells in each column doesn't exceed the rim condition, right, of that column, right? So 60 and 10 is 70, doesn't exceed it. 30 is 30, 40 and 50 is 50, doesn't exceed 50. All right, so it's a valid shipping policy, right? All demand was met and all supply wasn't exceeded, right? So we didn't ask of distribution center 1 to send more than it has. Okay, so this video is kind of getting long. We're going to talk about, I guess in the next video, more on the LCM. We're going to look at an example where it kind of does very poorly, and we'll just analyze what we obtained in solving this problem.